All right, today we are going to go ahead and continue talking about solutions or x-intercepts to quadratic equations. Today we're going to talk about how to solve quadratics using factoring. So solve quadratic equations using factoring. Okay, so there are three steps that we need to look at whenever we're thinking about how to solve a quadratic equation with factoring. The first thing you need to understand is, if I have a quadratic equation, say for example, x squared plus, let's do 5x plus 6. For example, if I have this quadratic equation and I wanted to find the solution, and I'm talking about the x-intercept here, what do I know about an x-intercept? The y value is going to be 0. So the first thing that you need to make sure is that your quadratic equation is set equal to 0. Solving quadratics is very different from solving linear equations. So your first step is to set the equation equal to 0. Once you have that equation set equal to 0, that's when we're going to factor. So we're going to factor our quadratic, and that's going to help us find the solutions or the x values that's going to plug into this equation and make this left side of the equation equal to 0. So we're going to factor this completely. Okay, and then after you factor this completely, so I'm just going to quickly show you the factors. And it's still going to be set equal to 0. Once you've factored it completely, what we're trying to do is we're trying to see what x values can I plug in so that way this equation is equal to 0, or this side of the equation is equal to 0. And factoring helps us with that because when you break down this expression into factors, now we have two things multiplying with each other. And when we have two things multiplying with each other and they need to equal 0, what happens is it only takes one of these two pieces being equal to 0 for it to multiply with the other, and then the whole thing equals 0. Because anything times 0 is equal to 0. So if this first piece equals 0, it's going to multiply, and now the whole thing is 0. Or if this second piece equals 0, it'll multiply, and then this whole thing will equal 0. So what we're going to do to figure out how I can get each factor, I have two factors, and I want to see when each one of them equals 0, I'm going to set each one of these individually equal to 0. So the third step is to set each factor individually equal to 0. And once you've done that, so for example, I would have x plus 3 equals 0, and I'd have x plus 2 equals 0. Once I've done that, now I'm going to solve them, and those solutions are my x-intercepts. Those are the values of x that are going to make this quadratic go to 0, so they are my x-intercepts therefore. So let's go ahead and put these steps into action and see how this can play out. I kind of showed you real quickly an example, but let's actually go through the process together. Okay, so here's our first example. X squared minus 9x plus 18. So what I'm going to do now is the first thing I need to make sure is that this equation gets set equal to 0. Sometimes they're going to give you equations like this where they're already, or expressions like this, where they're already set up in a way where you know it's a quadratic equation. You just need to put equals 0. So in this case, I'm just going to put equals 0 here, because that's our first step, just to make sure it's equal to 0. Sometimes, just as a quick aside, they're going to give you ones that look like this. Or they're not going to be already written in standard form, ready for you to solve. What you'd have to do here is you'd have to subtract everything on the right side, or do the inverse operations on everything on the right side to move it to the other side. So I'm going to do the opposites, and then I'm back to where I started with on this problem. Okay, so that would be how you do that. Anyway, on this particular one, it's pretty much ready to just set it equal to 0, so we can go straight into factoring. What's the first step for factoring? Find a GCF, and then we can do the x. So, is there a GCF other than 1 here? No. Don't forget to take the GCF out because it makes your process a lot easier once you've done that. Now I'm going to do my factoring x. The top, it's going to be a times c. So I get 18 up there, 1 times 18. At the bottom, it's b. So I'm going to put negative 9 at the bottom. Now we need to figure out what two numbers multiply to 18 but add to negative 9. Good, those are the answers. If you struggle with this, one tip, or at least for how to use Desmos to help you, is take your top value, divide it by x in Desmos, and then convert that expression into a table, and then your table is going to have the list of xy pairs that actually multiply to 18. So it'll list all the possibilities here. You can just find the pair of numbers that actually add up to negative 9. You might need to extend the table, but you can at least find it. Now that I have these two numbers, can I go straight to my answer, or do I need to do the box? We can go straight to my answer. Why can I go straight to my answer? Because a is equal to 1. When a is equal to 1, when the number in front of x squared is equal to 1, you can go straight to your answer. So my answer is going to be x minus 6, and it's going to be x minus 3. And this is still all equal to 0, because we're trying to find the or the x-intercept, because that's where y equals 0. All right. So now remember, the reason why we factored is so it's easier to see how can this piece equal 0 and how can this piece equal 0. Because if either one of them take on the value of 0, then the whole left side is going to multiply out to 0, because it only takes one 0 as a factor for everything to multiply to 0. And the easiest way to find those numbers is to set each factor individually equal to 0. So I'm going to take x minus 6, that's set equal to 0. I'm going to take x minus 3, that's equal to 0. And then we can see my x-intercepts are x equals 6 and x equals 3. I just added 6 on both sides for the left equation, and I added 3 on both sides for the right equation. These are my x-intercepts. And if we were to take one of these two values and plug it into my original equation, you will see that it is going to make that expression on the left go to 0. So let's do 3 because it's smaller. So 3 squared minus 9 times 3 plus 18 is equal to 0. 3 squared is 9. 9 times 3 is 27 plus 18 equals 0. And then 9 minus 27 is negative 18. Negative 18 plus 18, that does equal 0. So since this equation is balanced, it means I did find the right solution, and this factoring method did give us our answer. And real quick, again, remember there is an easier way to find your x-intercept for a lot of these. So factoring might not be your first line of defense for finding the x-intercepts or solutions to equations like this, because at the end of the day, you can just use graphing, put this expression or equation into the calculator, it'll graph the parabola for you, and there are the same x-intercepts as we found the first time when we factored. So this is just another tool for how you can solve quadratics, but maybe it's not necessary if you can use this calculator. Any questions about how we were able to use factoring to find what x values are going to make the equation equal 0? So I can actually find my x-intercepts using that. Okay. Then we're going to do a different example. We're going to talk about a difference of squares. I want to look at all four, I guess, types of factoring problems that I want you to be familiar with. We looked at one where a is equal to 1. Next, we're going to look at our two factoring rules, and then we're going to talk about where a is bigger than 1. So this time I'm going to set it up as x squared equals 49. So this time, my step 1 again, it says set the equation equal to 0. Is this equation set equal to 0? Is it written in a way where there's a 0 on one side? So what do I need to do to get this set equal to 0? What step? Yeah, if I did subtracting by 49 on both sides, now I'm going to have a 0 on the right and an expression on the left. So let's do minus 49 on both sides. And when I do that, these cancel, and I'm left with x squared minus 49 equals 0. So this is now an equation that's ready to solve by factoring. So now that I have it set up and it's ready to be solved by factoring, we need to think, what kind of expression or what kind of quadratic do I have? Does anybody remember what we could call this where there's two terms? It's a difference of squares, exactly. So we've got a difference of squares here, or at least it looks like it. You see two things subtracting, two terms subtracting with each other, and one is a squared term. Just double check because it's quite probably a difference of squares. So we're going to check to see, is it actually a difference of squares? I'm going to put the rule for it up here. It's a squared minus b squared is equal to a minus b times a plus b. So the first thing we need to check after we check that it's two terms subtracting is my first term a perfect square or perfectly square rootable? Yes, x squared, the square root is x. Is my second term a perfect square? Yeah, so now that I know they're both perfect squares and they are two terms subtracting with each other, now I can actually use the perfect square or the difference of squares rule to help me solve this problem. All right, so real quick though, I want to go ahead and label the different pieces of my expression. So this x squared here, that is my a squared. Basically all it's saying is that this term is a perfect square. When you square root a squared, that is what gives you your a value. So the square root of x squared gave me my a that I can use to find my factors. Same thing, the second term, 49, that's my b squared. And when I square root that, that gives me b. And now I can use the a and b, or the two square roots I found, to write my answer, or my factored form. So I can get square root minus square root and square root plus square root, or a minus b and a plus b. So my answers will be x minus 7 and x plus 7, my two factors here. And they're still set equal to 0. It's just now we have it such that these two linear factors, we can set each one equal to 0 and find my two x-intercepts. So I get x minus 7 equals 0, or x equals 7. That's one of my two x-intercepts. The other one, x plus 7 equals 0, or x equals negative 7. And that's my other x-intercept. And these are my two x-intercepts here. Any questions about how we were able to use the difference of squares to factor this time? But the main new thing is that once we've factored, we're trying to find the x-intercepts. So we just set each factor equal to 0 to find our x-intercepts. It's the difference between factor this quadratic, which means all you're doing is factoring, and find the x-intercepts, or find the roots, or find the solutions. And in that case, you have to set them equal to 0 after you factor. Okay, go ahead, turn your page. We're going to look at two more examples, and then I'm going to pass out some practice. Okay, so this next one, I'm going to write x squared minus 12x plus 36. So you should be really trying to get familiar with your perfect squares. And the second you see a perfect square as your first term and your last term, you need to be thinking, is this one of my special factoring patterns? In this case, we can check to see it's definitely not going to be a difference of squares, but it might be a perfect square trinomial. So let's see if this is. I'm going to set it equal to 0 before we factor, but to factor, I'm going to check, is this a perfect square trinomial? The first thing that needs to be true is that my first term and my last term need to both be perfect squares. So let's check. X squared, the square root of that is x. 36, the square root of that is 6. So these are both perfect squares. The middle piece is where things can get a little confusing. We have a positive version of this and a negative version of this, but it doesn't matter. Either or is a perfect square trinomial. So we really don't care about the sign here. It does change our answer. But the thing that we need to check is that this middle term is 2 times the product of A and B. And again, just like with difference of squares on the last page, perfect square trinomials kind of work the same way when it comes to A and B. Your first term, that's your A squared. And when you square root it, that is the A you're going to use in your factors. The second, or I guess in this case, the last term, that's your B squared. And when you square root it, that's your B term. Now, what we need to check is the product of these two square roots doubled? Is it the same as this middle term? So if I multiply them together, really, if I just took 2 times A times B, and I got 2x 6, I replaced A with x and B with 6, I get 2 times 6 is 12, times x is 12x. Does that match my middle term? Yes, it matches the middle term. So this is a perfect square trinomial. And when we do that, we can rewrite it as x plus or minus, or not x. A plus or minus b. So there's a positive version and a negative version. You're not going to use both. You're going to do one or the other. So in this case, I'm going to do minus because I have a minus here. So my factors are going to be x, because that's my a, minus 6, because that's my b, and it's squared. And that's still equal to 0. And now anytime you see a binomial written like this, where it's squared, you need to get in the habit of expanding the binomial. Make sure that you expand the binomial and not just square your terms. If you just square your terms on the inside of the parentheses, you're going to get the wrong answer. And now that I've expanded it out like this, now what I can do is I can set each one equal to 0. But maybe you'll notice they're the same. So what's going to happen is, even though you have two factors here, they both give you the same answer. So with perfect square trinomials, there's actually always going to be only one x-intercept. Okay, and again, that's the two special factoring rules. Really, the only new thing here today is that we're taking these factors and setting them equal to 0 to find my x-intercepts. But for the most part, this should be a good factoring review of all the different types of situations where you can factor. All right, I'm going to cover up like the top third or so. And what we're going to do is we're going to look at this last example. This is going to be an example where a is greater than 1, so I need to use the box. So 15x squared, let's do plus 4x minus 4. And again, we need to set it equal to 0 so we can find our x-intercepts eventually. Now, first thing you've got to check, is there a GCF on this one? No GCF, at least none other than 1. And now we can set up the x. 15 times negative 4 is negative 60. 4 goes at the bottom. And now take a moment, especially if you struggle with this, and think, what are the two numbers that multiply to negative 60 and add to 4? And again, if you need to use a strategy like taking your top number, dividing it by x, and turning that into a table, that might help you get a consistent way of finding the answer. Hopefully, you thought of 10 and negative 6. Those are my two factors. In this case, can I go straight to my answer like we did in the first one? No, the reason being is because there's an a value greater than 1 here. So I'm going to have to do a box method or grouping, either or. But since most of you use the box, we're going to use the box representation to help model the same strategy. So 15x squared goes on the top left. Negative 4 goes on the bottom right. So remember these two, my ax squared and my c, those two things go directly into the box. These two numbers, though, they need to go in the other spots in the box. But make sure, and this is a common mistake, that you don't just put 10, you put 10x. And make sure that you don't just put -6, you put -6x. And now we've filled out the box completely. To find the factors, we're going to figure out what are my GCFs of each row and the GCFs of each column, so that way we can see the factors on the outside of the box. Okay, first row, 15x squared and 10x. What is the GCF of that row? 5 is the GCF of the coefficient, and since there's an x squared and an x, I can at least factor out one x from both of them. Both of them are divisible by x, and both of them are divisible by 5, so that's my GCF. This next row, -6 and -4, have a GCF of -2. I'm going to take out the negative because the first term in this box is negative. When I read from left to right, the first term is negative, so I take out a negative. There's only an x in the first term, so I can't factor out an x from both. For the column now, 15x squared and -6x. The GCF of the coefficient is 3. But since there's an x squared here and an x, I can factor out an x from both. Notice how I didn't take out a negative. I only take out a negative if the first one is negative. My first one is positive, so I'm going to take out a positive. Now again, GCF, this time it's just 2. So now we can go ahead and write this as our factored form, 5x minus 2. And 3x plus 2, and it's still equal to 0. And this is one of the situations where it might be useful to actually do the factoring method because we're going to end up getting fractions here. So let's set each one equal to 0. 5x minus 2 equals 0, and then 3x plus 2 also equals 0. And then when we do that, I'm going to add 2 on both sides to move that -2 to the other side. I'm going to divide both sides by 5, and I get x equals 2/5. That is one of my 2 x-intercepts. For the other one, I'm going to subtract 2 on both sides. I get 3x equals -2. Then I'm going to divide both sides by 3, and I get x equals -2/3. Any questions about how we factored that one or how we found the GC or the x-intercepts?